Subhash, may I check with the speakers now? Speakers.
Yes, sir. Yes. Praveen ji, please video on kar leं. So, sir, all speakers from ISRO, they will be joining from same place. Sir. एक ही.
अच्छा.
जी. प्रवीण जी वीडियो ऑन कर लें सर.
उनके कॉन्फ्रेंस रूम से.
यस सर.
ओके.
यस सर.
Mr. Subhas, as I informed earlier, Director Sek would be joining little late. Yeah.
Okay. I think Chandra Prakash sir is also here. Praveen ji.
Yes, how are you?
Namaste sir.
Actually, Miss Vibha, due to some personal exigency, would not be able to join. So that's why Chandra Prakash sir has consented to deliver the talk.
Okay. Yeah. So sir will be delivering his talk.
Yeah.
Okay, fine.
Namaskar, sir.
Namaskar, Shanadam. How are you?
Fine, thank you.
Am I audible?
Yes, sir.
Yes, you can start now.
Subhash, shall we start?
Yes, sir. Okay, sir.
With your permission, sir, we start.
Yes, please go ahead.
Yes, sir. Thank you, sir. Thank you. Respected Sri Umasankar Pandey, sir, Member Services, Digital Communication, DCC. Respected Sri Raju Sinha, sir, DG NTI PRIT. Respected Sri Mukesh Kumar, sir, DDG NTI PRIT. Respected Sri Nilesh Desai, sir, in his absence, he will be joining soon. And respected all the speakers from ISRO, participants from DOT headquarters, TEC, TRAI, LSS, and all other units of DOT. A very warm good morning to all of you. Myself, Subhash Chandra Kesarwani. I am Director NGS here, and I will be coordinating for all this webinar, all the activities. So this webinar will have two sessions. First will be inaugural session, and second will technical session. Technical session will have 4 speakers from all from ISRO, and inaugural session starts right now. So for inaugural session, I invite Sri Raju Sinha sir to deliver welcome address. Over to you, sir. Please, sir.
Thank you, Subhash. Good morning to all of you in this webinar on NavIC IC opportunity for the telecom industry. At the outset, I welcome respected Sri Umasankar Pandey, sir, Member Services, Digital Communication Commission, DOT, for his inspiring presence in the webinar. In his leadership and guidance, NTI aspires to conduct many webinars on important and emerging topics. We are also privileged to have with us Sri Nilesh M. Desai, Director SAC ISRO, with whom we discussed, and he agreed to have webinar on this topic. He'll be joining soon and will be part of the program. So I welcome Mr. Desai also. I welcome all the distinguished speakers of today's webinar. Sri Praveen Patidar, scientist, he'll be giving overview of the system. And then Mr. Chandra Prakash will be deliberating on NavCom applications. And then Sri Kalpesh Varsadia from SAC ISRO on GNSS applications, and Sri Niskam Jain, scientist SAC, focusing on a telecom application of NavIC. I also welcome all the participants of the webinar joining from different part of the country, also from DOT headquarter, LSA, TEC, TRI, BSNL, MTNL, various telecom associations, academies, and our officers from NTR. So it is very exciting and interesting that many stakeholders are connected to discuss and deliberate on this very important topic. So in fact, we conducted a webinar on this topic in 2021 early, and where it was taking its shape. And then we discussed with ISRO with a lot of modification and applications. We thought it is again a good way to conduct this webinar for awareness and deliberation among all stakeholders. So, dear participants, telecommunication network, which is beyond our physical accessibility for regular operation, maintenance, and development, like submarine and satellite communication, has always excited us, and to those who are practicing telecom. The topic of today's webinar, NavIC opportunity for the telecom industry, is a very important and relevant topic for various reasons. NTI has a major role to play in facilitating this type of deliberation and interaction among various stakeholders. NavIC is another feather in the cap of Indian scientists and ISRO, giving live demonstration of their willpower, tenacity, and perseverance in developing cutting-edge technology indigenously. It is operational since 2018 through its constellation of Indian satellites, covering the whole of India and up to 1,500 kilometers of its boundary. We are here in the webinar, then why? So we'll be knowing what new is being done in NavIC and how citizens and various stakeholders can make maximum use of it. To us, it is gathered that to promote the civilian navigation use of NavIC, ISRO will introduce the L1 frequency, that is 1575.42 megahertz, in all its future satellites, starting from NVS 01 onwards, because L1 is the most established GPS signal, which even the less sophisticated civilian use devices, such as the smartwatches, are capable of receiving. Thus, with this band, the use of NavIC in civilian use gadgets can go up. Another thing, with the fully operational constellation and ground station outside of India, we understood that ISRO plans to set up ground stations in Japan and France also to better triangulate the entire area under NavIC coverage. The system is likely to become more accurate than GPS. The satellite placed directly over India also ensures better availability of signal in varied geographical region as compared to GPS. Through GPS, India receives signal at an angle that makes it difficult to access the dense forests or valleys. So that effort is going to a new effort of NavIC for the coverage part. Thirdly, the government is also pushing NavIC for its increased use in smartphones. Tech giants are required to make smartphones compatible with NavIC, which requires hardware and software changes. So the forthcoming smartphone is to support both NavIC and GPS. So with NavIC application in various sectors, we'll also be listening about NavIC application in telecommunication sector. So this webinar is expected to spread the awareness among telecom officers about the potential of NavIC and how telecom sector can leverage the capabilities of NavIC. I'm thankful to DDG Transmission and NGS and his team who made all-out effort in organizing this this discussion today. I again welcome all the participants and participants who are continuing in joining this webinar for their active participation. Thank you all to this webinar. Over to Spas.
Thank you, sir. Thank you very much, sir. After this welcome address by DG NTI PRITC Raju Sinha, sir, as per schedule, Director SAIC was due to deliver his special address, but sir has sent a message that he is already occupied, so he will be joining a little late. So sir has already said us to continue the program as per schedule. He will be joining. So following his instruction, I will invite Sri Umasankar Pandey sir, Member Services DCC, to deliver his inaugural talk on the session and declare this webinar open, sir. Over to you, sir. Please, sir.
Thank you so much. I am audible?
Yes.
Yes, sir.
And visible also?
Yes.
Yes, sir.
That's great. Very good morning to all of you, especially Mr. Sinha and the officers from ISRO who has been catalyst in designing this system. So the webinar topic is NavIC. This is a legendary name. If you go back to Ramayana era, the NavIC was there who sailed Rama to the Sri Lanka and he won the battle. So NavIC word in our ancient history carries a lot of weight, a lot of meaning to us. As the word itself says, NavIC, our Honorable Prime Minister has got a vision of Make in India. Sitting in DOT, whenever we have a talk or any problem depending upon security related deployment of equipment, etc., etc., every telecom equipment and network equipment goes through DOT only. So the Make in India aspect is always there. Even I'll just say we are discussing how to harden the computers and their networking system. Then we thought we are using Microsoft computers and just go for the computers across the country for the government department. They could be in the millions and millions and just multiply the amount. Then how much amount we are sending out? So why not develop our own system? That's the vision of the Prime Minister, and I'm very happy to see that it is being taken to the bottom level also. Whenever we talk of anything, the thing come in the mind, why not from India? So things are aligned, things and policies. Basically, policies are aligned in such a way that the products and other logistics being deployed in the telecom field, for which DOT is a nodal ministry to allowing all those things. This thing is being kept in mind. So today's topic, NavIC, the point came, I was told, in 1999 when Kargil war was being contested, we need GPS system, but USA denied it. If you say, if you deny some opportunity, that creates the opportunity for you. So I appreciate the denial at so many places, so many levels. Wherever you feel you are denied, you are cut short by 6 inches, but finally you get up and what 6 inches you go 2-3 feet high. So denial should be taken as a boon for the possibilities to be taken up. What is the, that is the basic principle of this government, governed by Honorable Prime Minister. He turns anything into opportunity. Any diversity, anything comes, it is an opportunity for the entire country. So especially, I'll congratulate my ISRO peoples who have taken all these pains and their intellectual property to design the system. And I was told that it is being deployed in the chips also, and some of the telephones companies are also deploying it. And it is better than the GPS. So teething problem can be there, and it can be sorted out as and when the problem comes. We have developed a system. I wish this system should be used extensively by our own people, by our own security people, navigation people, etc., etc. And while capturing all those things, it can be exported also. So we can compete the GPS at the World Forum also. So by today's webinar, one thing we appreciate NavIC and the capabilities of the NavIC and what are the shortcomings, where we can be given some time to upgrade it. Rather, you can point out whatever best can be done. That should be discussed today. And along with this, to whoever the participants, kindly take a note. This should not be limited to the people having this webinar over here, maybe 50, 60 people. This should be penetrated down below. Down below in the sense, if you ask the people, why don't you use the NavIC? People are using this Google Maps, etc., etc. They are used to. So shifting a person from a used to system to a newly developed system with teething problems is the real challenge. So unless people are motivated through one other region to switch over here, especially keeping in mind this is made in India and it will not be hacked, nothing will happen to your security, etc., etc. So the people will be convinced. So through this webinar, along with congratulating my scientists, I would also invite all the people over here to take such things in the society also, so that people, along with the NavIC, they can adopt so many things which is made in India, and the vision of our Prime Minister is taken forward. With this, I congratulate ISRO people again, all the scientists who are here and who are not able to attend the meeting. A lot of sadhuvat to them also, and especially for NTI, those who are arranging such webinars in the different fields on time-to-time basis. They're also in the line of getting appreciation from me. The frequency should be increased. Raju Sinha told that it was done in the 21, now it is 23. Why 2 years? So the memory fades away. The memory fades away. So keeping the memory, brushed afresh. So such type of things would happen not more than 4-5 months time. So any webinar, you keep it in mind. If you're doing some webinar, repeat it after 6 months. 6 months, things are getting developed. Some teething problems are coming. They are getting resolved. So it will be a continuous process. Your memory will not go fade up. So with all those words, I declare the webinar open and all the success for the webinar. And once again, thanks to all my senior officers sitting in the webinar, especially for the ISRO people who have taken all the pain to develop this system. Thank you so much.
Yes.
Thank you.
Thank you, sir. Sir, with your words, I have set the tone for this webinar. And now I invite Sri Mukesh Kumar sir, DDG and Transmission and NGS to deliver a vote of thanks for the inaugural session, sir. Over to you, sir, please.
Thank you, Suhas. Very good morning, ladies and gentlemen. On behalf of NDI, I would like to express my sincere gratitude to all of you for joining us today for the inaugural session of this webinar. We are privileged to have with us Sri Umasankar Pandey, Member Services, Digital Communication Commission, Government of India, who graced this occasion with his presence and shared his valuable insight with us. His vision and leadership have been a source of inspiration for all of us, and we are deeply grateful for your support and guidance, sir. Thank you so much, sir. Department of Telecom is very thankful to Sri Nilesh M. Desai, Director, Space Application Center, ISRO, Ahmedabad, in his absentia, for his leadership and being magnanimous to provide eminent speakers and expert of ISRO for this webinar. India expresses its sincere gratitude for his wholehearted personal effort in planning this webinar. Thank you, sir. I would like to thank the guardian of this institute, Sri Raju Sinha, Director General NTI, for his constant inspiration and guidance at each stage of planning and execution of this webinar. His loving presence always keeps the flame of learning ignited amongst all the officers of NTI. Thank you so much, sir. I would also like to thank our distinguished speakers, Sri Praveen Patidar, Sri Chandra Prakash, Sri Kalpesh Bursadia, and Sri Nishkam Jain for being with us with their insightful presentation on topics of webinar. Your expertise and knowledge are likely to enrich our understanding of the subject and stimulate our curiosity to learn more. Furthermore, I'd like to express our appreciation to Team NTI, specifically Sri Subhash Chandra, Director, and Sri Jaipal Singh, ADT, and the support staff of Transmission and NGS Division and the officers of Training and Administrative Unit of NTI for their wholehearted involvement to ensure a smooth webinar. Last but not least, I would like to thank all the participants for their active and soulful presence here. I would also like to thank the controlling officer of all the participants for sparing them to attend this webinar. As we move forward with the technical session of the webinar, we hope to have this webinar informative and insightful and have an active and engaging participation. Thank you once again and have a great day. Namaskar.
Thank you, sir. So with this, we come to end of our inaugural session, and we will start for technical session. So our first speaker is Praveen Patidar. So before that, just I want to check whether Director sir is available or we should proceed. Praveen ji, please just let me know accordingly.
Sir has not yet arrived, so we can proceed.
Okay, fine. And just okay. So our first speaker is Sri Praveen Patidar. Before he starts his presentation, let me introduce himself. Sri Praveen ji. Sri Praveen ji joined SAC ISRO in 2007 and since then working as system engineer for satellite navigation systems. He has contributed significantly towards the NavIC payload configuration, design, development of navigation payload, calibration technique, and signal structure definition of the NavIC. He also participated and contributed significantly towards bilateral inter-system coordination of IRNSS and Gagan with GPS, Galileo, Compass, and QZSS. Currently, he is involved in design of next generation satellite navigation signals, space-borne application of GNSS, and pseudo-Deloitte based navigation system. He has delivered talks and lectures at many organizations towards training and popularization of indigenous satellite navigation system. Prior to joining ISRO, he has worked with Wipro Technologies, Hyderabad. Over to you, Praveen ji. Please proceed.
Thank you, Mr. Subhash, and good morning to all the dignitaries and participants. Can you confirm if the slides are available?
Not now. Please just.
Yes, satellite
It
is
was
visible.
visible.
Slide is visible.
Okay. Achha, but I am unable to see. Okay. Okay, fine. It's visible then.
Yeah. Director sir is here, so maybe then we will have his address and then we can begin. Yeah.
Okay, fine. अनशेयर कर ले PPT.
Yeah, good morning.
Very good morning and welcome, sir. I am
Yes,
Mukesh
sir, please,
Kumar,
sir.
DDG Transmission and NGS at NTI.
Yeah.
So I heartily welcome you, sir, for coming to this webinar. And you have been very instrumental in getting this program executed by your personal effort and taking pain to design the webinar. So we would like to hear from you, sir. So I invite you to kindly address us. Thank you, sir.
Yeah. Thank you, and let me welcome all the participants and all of the dignitaries. And let me apologize for being late because I was held up in some other function. That's why I was requesting for slight shifting, but it has worked out well. So let me thank Mr. Subhas for working out all the details with our team, and we could manage it. Although we were ready by third, also we were ready, but there was some communication issues. So let me thank DOT for giving us this opportunity to present these details related to NavIC. And as all of you are well aware, India's this NavIC system, which earlier we used to call it Indian Regional Navigation Satellite System, IRNSS. Many of you may be aware about that. And then once our Honorable Prime Minister, he came to visit our Sriharikota launch center where we were launching one of the IRNSS satellite. So that time he said that you scientists use very complicated terminologies, IRNSS, nobody will remember that. So why not call it, he told in Hindi that why not call it, क्योंकि नाव वाले यूज करते हैं तो नाविक यूज के लिए उसका काफी उपयोग है, so why not call it NavIC? So he told in Hindi, then we converted into a English acronym, NavIC, so navigation with Indian constellation. So that's how this new name came, and now it is well known as NavIC. So that is the genesis behind these terminologies of NavIC. And as all of you are aware, it is a regional system covering India and its 1500 kilometers. Praveen is going to talk you more about the basic system, constellation, configuration, and many other relevant details. But let me tell all the participants that this today is also a very important day for us, 10th March, because one of the IRNSS satellite, 1F, was launched on this particular date in 2016, IRNSS 1F. So incidentally, we are organizing this seminar. We could not do it on third, so it is in that way, it is a very good coincidence that we are holding it today. So 1F was launched. So of course, it is a constellation of 7 satellites, and many of you may be aware that we are right now slightly struggling to make it operational because of some of the satellites running into a problem of atomic clock, because the basic timing is derived, either you put complicated circuitry in the receivers, which will increase the cost of the receivers, and that is not a viable thing for any navigation system. So generally we try to complicate or use complex technology in the spacecraft. So that way this atomic clock, which gives you very ultra high stability, long term and short term both. So it is around 10 raised to minus 13 to 10 raised to minus 14 second. That sort of stability means in so many lakhs of years, it will deviate by only 1 second. So that is the requirement of this atomic clock. And we use 3 such clocks in each satellite, but still all the 3 failed. So that was an imported clock. And I'm happy to tell you that the next satellite is ready for launch. Just we are waiting for government approvals. Otherwise, from technically it is ready. And that will use one of the indigenous clocks. So we have designed now, instead of depending on foreign sources, we will design our own clock, and that is ready now. First clock is ready, although we have done a lot of experimentation on ground, but the proof of pudding is in eating. So let it fly, because we may find some unknown issues when it flies in this vacuum in the sky. So we are putting our first clock, so 1 indigenous clock and another 3 atomic clocks, imported clock. Now the problem, we could trace it, and that has been rectified, conveyed to the vendor in Switzerland. So they were rectified this clock. So in fact, 4 or 5 satellites of ours face this problem. That's why we are, as I said, we are struggling to make it operational. But shortly we will be replacing all these satellites with our indigenous new satellites with our own clocks, and we will solve the problem. So it will soon get ready for operationalization, and government now wants us to go global also. Right now, as I said, we are a regional system which is operational 1500 kilometer in and around our country. So of course Navy wants to use it, so it it covers Indian waters also. But finally we want to make it global, like GPS or GLONASS or Galileo of Europe. So that is the plan basically, and more details Praveen will be anyway telling you. But what I would like to emphasize is this particular seminar or workshop webinar we have organized, keeping in mind your specific requirements. After giving an overview, we will emphasize more on NavCom applications. As the name suggests, now the trend is toward using, there are two trends. One is having a multi-GNSS system. Now nobody, no country or no user depends on only one constellation. So you use GPS, but along with that you use signals from other constellation also, because signals are available free of cost. So receiver is now built in a complicated way so that it has multiple channels. So it will receive signals from all these satellite constellations because signal is free. And try to find out solution based on this multiple GNSS system. So that is one trend. Another trend is using now this position information to convey it to a remote place. So communication come into picture. So navigation and communication, a combination of both. That's why it is called NavCom or ComNav, communication and navigation. So that is one major area of working. So that is what we want to emphasize. And apart from that, all telecom related specific applications also we are covering in one lecture. So all in all, it will cover the right from the basic aspects to the actual complicated and complex applications. All aspects we are trying to cover. And of course, ultimate is NavIC in mobile. That also a lot of work has happened, and that also our team will tell you about what is the situation as on today. So many, we have a list of mobile which has this facility of having these NavIC solutions, and we are trying, of course, with the help of MATI and DOT, to try to bring a regulation so that it will become mandatory. If you go in Russia and China, it is mandatory to use Beidou or GLONASS, although you can always use GPS. So in same way, if our government also brings such regulation, then that will help to penetrate NavIC further as far as its usage is concerned. And telecom, another usage will be, apart from NavCom, will be these timing solutions and synchronization of all the networks. And if, of course, for our strategic forces, we have lot many applications lined up related to timing as well as NavCom. And we have that some of the application demonstration will be given the part of this seminar. So all in all, it encompasses all these aspects. And once again, we are thankful to DOT for giving us this opportunity. Incidentally, today is also the birthday of our earlier chairman, Professor U.R. Rao. So in that way, very happy coincidences of many things, like INSS 1F launch, U.R. Rao's birthday. And just now I was coming from our Central Industrial Security Force Sthapna Divas, raising day was today. So we have many activities lined up for today, and this webinar has come at the most opportune time. So once again, I thank DOT officials and all the team members who helped us in facilitating conducting of this particular webinar. So thank you all and wish you all the best. And whatever your queries, we can take it further and we can organize. Recently we had a dedicated SATCOM communication related course for your team. So something similar once if you show interest into this navigation activities, and as I said, NavCom activities. So we can also think of having more dialogues in future about this. So once again, thank you all and wish you all the best. Thanks.
Thank you very much.
Thank you, sir. So with this, I invite Sri Praveen Patidarji. So please continue, sir.
Okay.
Yes.
Suhas, before we proceed, I would again like to thank Director sir for sparing his valuable time. Just after I have participated in the CISF Sthapna Divas Sir, as you told that today is the auspicious day, so I would again like to congratulate for having this seminar on this day when INS 1F was launched, and incidentally, this is the birthday of Professor Yuva Rao also. So congratulations, sir, and thank you once again for being so instrumental in getting this program conducted. Thank you, sir.
Thank you.
Yes, sir. Sir has given very good value to this date. Actually, we are not aware of all this.
Yeah,
Yes, sir.
coincidentally it happened.
Yes, sir. Yes. Thank you, sir. Thank you very much.
We continue with Praveen's lecture now.
Yes, sir. Please, Praveenji, please proceed.
Yeah.
Please.
So, very good morning to all the dignitaries and participants, Director Sec. I will be just briefing about the NavIC system overview, and wherein we will be touching about the system architecture, the services, current status of this system, its performance, some of the differentiators with regards to other GNSS systems. And I will be dwelling upon little bit on new services that are in line, as well as some future prospects with regards to NavIC system. As the directors are already briefed on this, NavIC stands for Navigation with Indian Constellation. So we pronounce it as NavIC, which was earlier known as the Indian Regional Navigation Satellite System. It's an ISRO initiative to build an independent satellite system to provide the position, velocity, and time services over all the users over Indian region. It's an independent satellite system fully under Indian control. Of course, it's a regional system catering to Indian landmass in the region extending to the about 1500 kilometers around the Indian geopolitical boundary. So there's the zone which we cover. This shows the service area, wherein you can see the white colored polygon is the NavIC primary service area, which the 1500 kilometers boundary beyond Indian landmass. But incidentally, the signals of NavIC are not restricted to this area itself. The signals goes much beyond this area, and we call it a secondary service area also, wherein also NavIC signals would be available. The performance may not be as good as it is in primary service area, but we will get services beyond that also. So this is the area where we focus, and there are requirements and requests from our end users to extend this even beyond these zones. So that also we'll touch upon a little later. If you look at the services and signals from NavIC, there are three kinds of services which are there. Two are positioning services. One is the messaging service. So in positioning also we have two categories. One is the standard positioning service, which is an open access service for all users. So, and the targeted positioning accuracy for that is 20 meters. Of course, we are getting much better than that. That also will come upon later. The other service in the positioning domain is the restricted service, where the access is not free to all. It's restricted and meant for authorized users only, primarily for our defense and strategic users. And it can potentially provide better accuracies compared to our standard positioning service. And more importantly, it's robust for challenging operating scenarios, which is demanded for such a defense and some of these strategic applications. So it's a tailor-made for those users. The other new addition to the service in NavIC is the NavIC messaging service, which is a unique capability compared to other GNSS in NavIC, where we can provide message broadcasting services with a low data rate, but a message broadcasting services to the over the entire NavIC service area. So this is something which is not there in GPS or other systems, but available with NavIC. Signals wise, NavIC transmits signals on dual frequencies. One is in L5 band, the other one is in the S band of spectrum. And we provide dual frequency signals for whether it is a standard positioning service or the restricted service. Both the services are offered with dual frequency signals, so that the ionospheric corrections are available to all the users. So in a nutshell, compared to legacy GPS, this is going to be much more accurate compared to the legacy GPS. Of course, the modulations are direct sequence spread spectrum modulations with CDMA for multiple access. The SPS, which is the open access service, is transmitted as a data signal only. which serves the dual purpose of ranging as well as data communication. To meet the robustness requirement of restricted services, it is transmitted as two separate components, one catering to data communication and other catering to ranging services. And as I mentioned earlier, we operate in two frequency bands, L5 band, which is about 1.1 gigahertz, and the other one is about 2.4 gigahertz. So these are the bands where NavIC signals are available. There is an addition to these frequency bands, which I will touch upon later on. I will not go much into the technical aspects of how the system functions, but just to have a brief idea, any SatNav system basically consists of three segments: the space segment, control segment, and the user segment. Where the space segment is consists of a constellation of satellites, and they are basically designed to downlink navigation signals, and along with those signals, their own positions. There is a big infrastructure on ground as part of control segment consisting of monitoring stations and master station, which will continuously be observing the signals broadcasted by the satellite and provide the relevant corrections to the satellite itself. And then there is a user segment which basically carries out the ranging operation with satellites and estimates its own position. So if you keep the user segment apart, among space segment and control segment, there is a continuous feedback loop going on, and the entire system is working in harmony in order to deliver the required services to the user segment. So this is how the system functions. If you come to NavIC space segment, so it consists of 7 satellites as of now. 3 of them are in geostationary orbits, and 4 are in geosynchronous orbit. So, yeah, so the satellites at 32° east, 83° east, and 129.5° east are the geostationary satellites. And then we have 2 geosynchronous satellites at 55° east and another 2 at 111.75°. So, all in all, it's a 7 satellite constellation and focusing their signals over the Indian region as we displayed earlier. Some of the photographs of the NavIC first generation satellites are here, and one can see it's going through various phases of testing. And if we coming to the NavIC control segment, so there are a lot of systems involved here. One of the INSS Navigation Center, which is the heart of the entire control segment. This is located at Bailalu near Bangalore, and its one mirror image is basically at Lucknow in UP. So these two controls are the heart of the control segment, and in eventuality of any issues with any system, it can seamlessly switch over to the other hot adrenaline system. And these navigation center is supported by various other facilities like network time, spacecraft control facilities, range and integrity monitoring stations. So these range and integrity monitoring stations are basically the receivers, highly precise receivers, which are installed across the length and breadth of our country. And in fact, we are planning to install them out of country also in order to get the better visibility of the constellation and in turn get better accuracy later on. There are CDMA ranging stations, and then there is a data communication network to connect all these ground segment elements together. So this is how the entire infrastructure is.
मैंने एक्सेल शीट आपको भेजी हुई है सर, तो उस हिसाब से भी डिस्कशन हुई है, तो 1-2 पॉइंट है जो आप एक बार देख ले तो
others can mute. We are getting. Yeah. So if you look at the interaction among the NavIC segments, the space segment and the control segment. So these are the NavIC satellites and the various elements of NavIC control segment on ground. So what is happening is the NavIC satellites are transmitting the navigation signals in L5 and S-band, which are being received by our monitoring stations across India. And these monitoring stations transmits their observations to our master stations at Bailalu and Lucknow. And in addition to this monitoring, some of the two-way ranging stations perform the precise ranging of the spacecrafts also using CDMA-based ranging signals. And those observations are again also collected at the master station. The master station in turn also get the time synchronization inputs from our timing centers, and occasionally we do a laser ranging of all these spacecrafts as well. These spacecrafts are equipped with laser reflector so that we can do much precise ranging in order to validate the entire ground segment operation. So master stations, getting inputs from all these observations basically derives its own corrections, which are they're supposed to be provided in the signals that are transmitted by satellites, and then through our satellite control facilities, it is uplinked to satellites, and then the user receives the signals and get its own precise position. So this is the continuous operation that is keep on going in background for the entire network. I will not dwell much upon user segment. My colleague would be speaking more about that. But then there are plethora of chipsets and receivers, modules, and products are now available, which supports NavIC and going into the mainstream applications. Coming to the status, currently there are 8 NavIC satellites are in orbit. In fact, 9 were made and launched. One INSS 1A to 1I. Out of which, as Director SEC informed that 4 satellites, they had some failures in the reps, and that's why those satellites are not being used for the navigation purpose. But as I mentioned, the new service of NavIC, that is NavIC messaging service, so these satellites are now repurposed to fully dedicated on the messaging application. Of course, one satellite INSS 1H could not be placed in correct orbit due to the launch vehicle failures, and the replacement satellites of these 1A, 1D, 1E, and 1G already replacement has started, and INSS 1A was eventually replaced with INSS 1I, which is healthy and providing good signal. Meanwhile, the new satellites, they would be basically a new series, new platform with new capabilities, and first satellite, as Director SEC has informed, is already ready, and as soon as we get approval, it will be launched this year. And following satellites would come in regular intervals to make the constellation operation. Coming to the performance, so as I mentioned in the beginning, we offer signals on L5 and S-band dual frequency signals. But any single frequency can also independently operate, and we have made our targets of 20 meters as a single frequency accuracy target, and about 20 meters for the dual frequency accuracy. What is being received in single frequency is about 10 meters, and for S-band is about 7 to 8 meters. This is based on data collected across India from various receivers installed, and then as average performance over Indian region. And with dual frequency, we get about 5 meters of positioning accuracy over India. So this shows the current performance. Of course, when the constellation was fully populated, this is how we have got. Currently, since the 4 satellites are only beaming navigation signals, the performance could be little bit deteriorated at some time. But eventually, when the satellites are replaced, we will be getting this kind of performance. I will just dwell upon little bit differentiators because it's a common thing, like GPS and other systems are being used. What is it that makes us different? So apart from providing the basic positioning services, the flexible message structure that was envisaged as a NavIC signal, that enabled us to provision it for new services, like I mentioned the messaging service for that matter. The other aspect is that some of our satellites are in geo orbits, geostationary for that matter, and the geosynchronous also, which means that over India we can expect very good elevation angles for these satellites, and we can say that the availability of satellites in the urban areas is expected to be better over India. So that's one of the major differentiators. The other thing is that the Indian region is basically ionospheric turbulent zone, where the errors due to ionosphere is large, and it needs a tailor-made solution. So we had developed a grid-based ionospheric correction model in order to support the single frequency receivers achieving a good performance over Indian region. So this is something which is unique to us. The other aspect is that all the GNSS, they broadcast signals only in L-band. Even dual frequency are also in L-band. So in addition to L-band, we offer signals in S-band also. So there are a lot of communication services, terrestrial as well as Telecom services are there in this band. So there is an opportunity of harmonizing the applications and terminals, utilizing this fact that the navigation and communication signals are closer to each other. NavIC messaging service, as I mentioned, it's a unique feature wherein any user can register and upload messages to our control center, and control center through our uplinking center will uplink this message request to satellites, and then it can be broadcasted to the users. I think my colleague would be dwelling more about the actual applications and where it is put to use. So maybe we can skip to that question. If we consider the way ahead, as I mentioned, replacement satellites, for continuity is already in pipeline, and 5 satellites are in pipeline. First of which is already ready for launch, and second is ready for testing. The service enhancement and expansion is already been touted about, and the additional satellites beyond these replacements are being planned to increase the accuracy and coverage of NavIC. This is basically reflecting our end users' desire to increase the NavIC footprint. One of the major figure of merit for any SatNav system is time to first fix. Like you switch on the receiver, and what is the time it takes to give you the first position output, because it is very critical for our mostly strategic applications. And we have targeted 10 seconds, and I'm happy to share that we have in fact achieved and delivered that to the end user. So this is something as far as our knowledge goes, the best in class performance among all GNSS. And as Director Sec mentioned in his address, that now we are proceeding with our indigenous atomic clocks in our future satellites. The picture that you see on this slide is basically of our indigenous atomic clock. There are new signals and services also we are now contemplating. In fact, one of them is already fructified. The new signal that is being added into NavIC is in L1 band. Now, the L1 band is a prime band for global mass market GNSS application. In fact, all the location-based services and applications and timing and all domain, wherever we see GPS, it is basically coming from this L1 band, the 1.5 gigahertz spectrum only. And although we didn't have any signal there, but now the coordination activity with regards to that is completed, and we have already incorporated the signal in NGS01. And this signal is on performance is expected to be on par with the state of the art signals with data and pilot component for civilian also. And this would be a civilian signal, open access signal only. And the signal elements, which includes the codes that are being used, channel coding techniques, the modulations, these all are developed with indigenous technologies, and ISRO holds the IP for that. If you wish to get more details on this new signal, so draft ICD is already published on ISRO website. The link is mentioned on this site, so you can go there and download the document and get more details on what is there in this new signal. The other aspect that we are now working on is providing authentication service. See, in civil GNSS signals, one of the major threats is of spoofing. There are incidences increasingly of the increasing spoofing is now being reported, which lead to receivers being fooled in some other position or timing by virtue of adversaries. So the navigation message authentication is a NavIC in NavIC SPS is proposes to provide the data authentication as a value-added provision, wherein it can provide receivers with an assurance that the received navigation data is coming from the system itself and has not been modified by any adversary in between. Our signals, which are meant for strategic services, they are designed to be spoof free from all spoofing attacks, and they are tolerant to that. Civilian signals are not. So this authentication service can be a middle ground for civilian users to get this additional provision compared to what is there with the strategic service. And it will offer robustness for applications in critical infrastructure and services such as telecom, power transmission, or maybe critical cargo tracking, internal security, etc. So that's something which we are working on. Maybe in the coming time, we'll be declaring this also for the usable. And what lies ahead? I mean, as the Director Sir has mentioned, the government wants us to work on towards expansion of NavIC now. So ISRO has already started working towards that in a phased manner. So from regional to global with additional MEO constellation. MEO stands for medium Earth orbit, where the satellites would be located at about 20,000 kilometers altitude, similar to what GPS and other operators are doing. So that work is already in line, and we are working towards designing of such a system. Along with that, additional services with additional frequency bands, wherever the other GNSS are operating, in order to take benefit of already existing the technology for developing receiver technology. So we are contemplating signals on L2 band, some new signals on L1 band. Also, the high accuracy service, which will cater to autonomous vehicles or our survey applications, would be in line. Authentication service, as I already mentioned, and emergency warning service is also been contemplated, which in fact being discussed as an interoperable provision among all GNSS. So to be provided in future on global basis, and we would like to be part of that. So we are working on that. There are many more things which are coming up, and we are working towards that. So that's all. Thanks for your attention, and that ends my presentation.
Thank you, Praveenji. So very nice presentation. So now it's time for second speaker. So second speaker is Sri Chandra Prakash sir. He will be delivering talk on NavCom application. So let me introduce himself. Dr. Chandra Prakash sir received. I'm audible?
Yeah, you're audible.
Yes, thank you. Okay. Dr. Chandra Prakash sir received BE degree in Electronics and Communication from BIT Ranchi, 1998. He has completed MTech from Indian Institute of Science in Satellite Communication, Satellite Technology and Application from Department of Aerospace, IISc, Bangalore. He completed his PhD in Wireless Communication from Dhirubhai Ambani Institute of Information Technology in 2020. He is working in SAC since 1999, and he is there. He is heading Satellite Communication and Technology Division right now. He is the recipient of ISRO Young Scientist Merit Award and the Team Excellence Award for his novel contribution towards organizational goals. Besides the SATCOM applications and engineering, his research interests include the compressive sensing of wideband communication. Over to you, Chandra Prakash sir. Please proceed, sir.
Thank you, Suhas. Good morning, all the participants. Am I audible?
Yes, sir. Yes, sir. Please go.
Yeah. Good morning, everyone. This is an opportunity for me to talk on behalf of Vibha, which she could not make it today because of personal exigencies. So in next few slides, I'll just try to give you a glimpse of what we have contributed towards building these NavCom applications, keeping in essence of Atmanirbhar Bharat. So I take pride in saying that all these technologies which we have listed here is a good combination of navigation and communication applications, which has been done completely based on indigenous technology. It's all homegrown technology which we have done. So for different users, some of them has been implemented or is being implemented at national level. Some of them are still in pipeline. So I'll just quickly go one by one. I think the slides are not. Some issue with the slides. We'll open the PDF. That will be in the PDF. Sorry for this. Wherever those videos are there, they may not be visible, but at least you will be able to get it. Yeah. So this is the first application where we have done for Indian Railways. Indian Railways, we had two actually, what you call it is MOUs, which we did for Indian Railways, and tried to do two applications for them. The one is the real-time train tracking information system. This was a project which has gone live now, and the another was automatic warning at unmanned level crossing. So these two applications were taken up. They were developed based on our own
Gagan receiver initially, and now it is NavIC based GNSS solution is being utilized together with the mobile satellite service.
Chandraprakash sir, sorry to interrupt. I think that this slide is not some overlapping is there. So just please check. I think for me it is
I think you will have to stop and
this slide. Yes.
Just 1 second. I think the PDF was changed, but the old one was visible. Yeah.
It is not clearly visible actually.
Just 1 second. 1 second.
Yes. Yes, sir. Now it is good.
So what will happen is, I think you will, the videos will not be visible then in that case, but you will have to kind of.
Okay, sir.
Okay, we'll take it up as and when. So this is now it is visible. Okay.
Yes, sir. It's visible now. Please proceed.
So we did this first application for Indian Railways, wherein the real-time train tracking information system. These are the 5 important features which we have addressed. So the problem with Indian Railways was earlier, like you talk about the Indian Railway, it spans across the geography of the country. But the train information, the position information was earlier being manually fed by the station masters. And the stations are far apart. Some places may like roughly around on an average 8 kilometers apart. So what was happening is, and these were like manually fed, so there were timing errors in the reporting the position by the station masters. So the routing of the traffic at the junctions were being done through a software, they call it control office automation, which was not very efficient. And then like if the train has got like stopped in between 2 stations, there was no way to cross check whether the track is vacant for the next trains and or not. So those kind of operational inefficiencies were there. So keeping that in mind, this real-time train tracking information system was developed, which does the train tracking, where position of each of these trains are reported to a central location every 30 seconds today. The second is like this system which we have done for Indian Railways. They have got a built-in software, basically logic, which takes care of if it is what is going to be the next time of arrival to next station, what is the time of departure from a station, the run through if the train is not stopping or any unscheduled stoppage has happened between 2 stations. All these events are being generated automatically and being reported periodically to the central location. Besides these two, there is a two-way messaging feature. So a loco pilot can send an emergency message to the control station, and control station can send any weather-related information or any other emergency broadcast to the loco pilot. So that is another unique feature which has been built into the system. There is a SOS feature. Earlier, what happened is the train used to meet with an accident, and then the bogies fall on the neighboring track. And the train coming on the neighboring track didn't have any information about the accident, and then they will come on the neighboring track and hit the fallen compartment and met with the accident further. So these kind of situations has been reported in the past, even in Madhya Pradesh some 3 years before this situation was there. So we built a feature called SOS feature. So whenever their accident happens and the loco pilot presses that SOS button, that information immediately comes to the central location and it knows precisely that SOS button has been pressed. So that position, along with the position information, it does a rebroadcast to that information to all the neighboring trains within the vicinity of 10 to 20 kilometers. It's a software configurable, so that they are made aware that the accident has happened in that area and you don't have to venture this. So that is another feature. And then emergency broadcast, as I said, is weather related. So all these 5 features are today being supported, and this has been one of the very successful, NavCom application. How the system functions is right now there is an outdoor unit on the locomotive which is mounted on a train, and there is an Indian Rail Navigator, that is an indoor unit which is loco pilot uses that. And that information through S-band trans-receive system, the mobile satellite service is being utilized. GSAT-6 is a satellite. So it comes to our Earth station at Delhi, and that is being routed to CRIS, that is Center for Railway Information System, where there is a complete data center is there, which takes care of the control office automation job. So they also read out this information to passenger call centers and all the mobile apps. So this is today presently being operational. One important feature here, you are not able to see the video, but just wanted to tell you that this is a hybrid system. It takes care of the availability of the system has to be more than 99% for railway to operate purely on this. So the outdoor units actually is a hybrid system. It doesn't only work on satellite. It also has got a GPRS modem, and that too two GPRS modem into this. So it's a hybrid communication system where the information about the position is being transmitted through satellite as well as through GPRS. So there are two modems, GPRS modems addition to that. So if suppose the train moves into a tunnel, the satellite link may not work, but or it goes into a shaded region on the platform, then satellite connectivity may not be there, but through GPRS the systems are, these position informations are made available. So this is some of the views which and we have provided a complete GIS system in the rail navigator where the loco pilot can enter at the beginning of the journey, he enters the train position and he is also able to get information about the route which he is following and his estimated time of arrival to next station and all that information. Now there is an effort which has been initiated and in future we plan to integrate the signaling system along with this to provide in-cab signaling so that it becomes it can be even used for collision mitigations also. Avoidance rather, not mitigation. That's not the calculation. So right now with these two modems, this is the older data. Now we have crossed 99.9%. So the availability of these events are being successfully generated. The system is available for 99.45%. So wherever there are outages, the GPRS comes into picture, and wherever there is GPS connectivity is not there, Telecom takes over. This was again a video. Somehow, since we have moved to PDF, this video is not visible, but I'll switch on to the next. This is unmanned warning, automatic warning at unmanned level crossing. What was happening is India initially, few years back, in 2016, when this MOU was signed, there were a lot of unmanned level crossing. And so they came up with the idea that whether there could be a system which can provide automatic warning. So we did this system, again, same system, same way, but only thing is there was a trans receiver placed at the unmanned level crossing, which was like the train, the moment it puts a loco pilot, enters that a start of journey and train number, it knows that which route it is going to follow. So, and on that route, the GIS map was stored into it. So there were already pre-marked unmanned level crossings were there. Well surveyed location of that unmanned level crossing was there. So it used to compare its present position with the unmanned level crossing. And the moment it is less than 2 kilometers, the hub used to send a signal to generate the automatic warning at unmanned level crossing, and then the audio visual alarm will go on the unmanned level crossing when the train is 2 kilometers away from the level crossing, and after it crosses again a signal will come from the hub to switch off that. So that way automatic a warning was generated at unmanned level crossing. This was showcased in this is on the left hand side. Of course, as I said, probably we will run this video towards the end of this lecture. But on the left hand side, this was a solar panel enabled. This system was there, which has this system installed at unmanned level crossing, which was used, and this was demonstrated in Hajipur section. So over and all, this NavCom system for Indian Railway provided all-weather navigation system, improved the safety, improved the efficiency and user experience. In first phase, we had 2,700 locomotives, and second phase with 6,000 is already ongoing. More than 1,200 has already been installed, and it's an ongoing process with Indian Railways. Last year in Niti Aayog actually appreciated this effort. They said that probably this is one of the very good example where the data has been put to use for improving the public safety of life. And last week, I think on 10th of last week, 7th of this March, there was a webinar, and there this has been all the benefits of this particular project has been projected by the railway department to the concerned ministry, and they are very happy with the services. This is another NavCom services which we have done, wherein we are trying to. India has got a very large coastline, maritime domain. We are all aware that how we faced the problem of 9/11 when the attack happened on Mumbai through the marine route. So after that, the government of India, under the directive of NCS-MCS, which is a National Committee on Safety and Maritime Domain. So basically, they asked us that whether we can have a system through which we can monitor all our sub 20-meter assets, because their idea is they want to monitor each and every assets in the oceanic region or in the maritime domain, that either it belongs to us or belongs to some other country. If it doesn't belong to us, they are called the dark targets. So they want to monitor those dark targets. So for that, they need to know where our assets are. So under that directive of NCS-MCS, we developed this NavCom system, which is again a S-band trans-receive system, as we explained you in the railway case. Only thing is here the position reporting rate is every 15 minutes. So all these assets, small boats are fitted with trans-receive system, and it is slightly different system that this terminal has got a Bluetooth connectivity, and we have done a mobile app, Android app for fishermen, using which the fisherman can send an emergency message or receive an emergency message, and they have different needs. Fishermen, when they go for fishing in deep sea, while they do not want to be tracked because of their economic reasons, because they get a catchment at a particular place, they go for fishing into a particular area and they get a good catchment. They want to remember that route and they want to follow that route. So they want to use navigation for that purpose. And whereas the security agency wants to monitor their movement. So how to meet this contrasting requirement? One person wants their position to be known. Other person doesn't want their position to be known, but they want to remember the route. So to circumvent that problem, we built this Android app, wherein a resident software is there which remembers the route which it travels on the previous last 10 days, and it keeps it in memory, which is only known to them. Whereas whatever the position being reported every 15 minutes is made available to the security agencies on one-to-one basis for monitoring purpose only. So this system was developed in which all the features of RTIS is supported. Besides that, there is an additional feature where the potential fishing zone or weather-related alerts are transmitted on daily basis to the fishermen to improve their livelihood. So they get a potential fishing zone information which is being generated by inquiries. That information gets uploaded, and there are other applications like if the boat they have got a certain predefined emergency messages. Like if their boat catches fire, they can send a fire alert. They can send a medical emergency alert. So those alerts are given. So we built this application and provided to them. This is again the video will not work. This is how it has been rolled out in Tamil Nadu now. In Tamil Nadu, 5,000 boats are fitted with this. On the right hand side, you see the MSS terminal, which is a smaller one, and there is an indoor unit. If their mobile doesn't stop working or battery of the mobile has got discharged and the Bluetooth app has got any problem, then in that case, we have provided an indoor unit where there is a button provided and a speaker provided. So there is an audio visual alarm plus there is a button by pressing which they can send a manual emergency also. So that provision also has been done. This is getting live now. Now Department of Fisheries is trying to has agreed upon to implement it at a national level. So this is some of the technical features for those who are interested. We have built this terminal in two different mounts. One is pole mount, another is surface mount. And this is the specification. It has got a nearly omnidirectional coverage, which is required for this. This is how it is being nationally rolled out. So whatever signals are being transmitted by this boat through GSAT-6 satellite, it comes to our hub, and it is enabled by NavIC enabled a GNSS system. So it receives GPS, NavIC plus other services also. Right now we have gone for GPS plus NavIC, but as I said, these receivers are reconfigurable for different modes. This data comes to our ISRO hub, and from there, using a cloud-based distribution network, we are distributing it to different agencies, and each of these states has got their own user network management system. So each state is managing their own terminal separately. They manage their own traffic separately. They manage their own warning separately. They manage their own supply chain also separately. So that's how we have done it. This is the network infrastructure which we have established at Delhi, through which all the estates are being connected, and to get their respective data and do this. So this has got a very unique national level implementation where we have worked out a unique terminal management, what do you call it, and numbering a scheme for each of these terminals based on the feedback from Department of Fisheries. I am happy to say that Department of Fisheries has, on a national level, now they have, through NSIL, they are now coming up with its implementation for 1 lakh boats. So this is some of the features where you see the Fisherman app, wherein the fisherman can send, like, it's like a very friendly, user-friendly app which has been developed. So like SMS, you can use a fisherman, because there is no other means of communication in maritime domain. This becomes a lifeline for them. So they can send a message or receive a message. And on the left-hand side, if you see, we have given their geolocation of all the harbors, all the routes. My routes is one of the feature which is widely used by this fishermen. So wherever they get a catchment, they store that their route, and next day they ask that, like, simply the app to follow that route, and they go to the same place and get the catchment. So all those features are given there. This is for there is another Android app which has been done for the owners. So a owner can have 5 or 10 or 20 boats. So he can see their position of respective position at any time. He can talk to their loco pilot using this app. So he can talk to his, now this app we are modifying it. I am happy to share this also is a development that now the fishermen, they go for fishing, they get a catchment, they get different kinds of fish. Like today they have got tuna fish, and tuna fish is required in the market. So they can, like, now this app is being updated now, wherein they will be able to report in real time that how much catchment they have got, what kind of fish they have got, and by the owner will know a priori that they have got today, they have got this much catchment of this category, and they will be ready by the time they come to the harbor. They will be ready with the buyer on a negotiated price. So it will improve their livelihood and supply chain management issues. This is the user network management for the control authority. Like, each of these estates, they have got certain regions which are no fishing zone. So they want to do geofencing in that area, and they want to control that nobody should enter into that and do fishing in that particular area, because they want to kind of improve the maritime habitat. So there is a geofencing feature on this NMS. So they can do just a geofencing, and if anybody enters into that area, they will get an alarm that you are entering a forbidden zone. You can't do fishing here. And they will similarly, that alarm will get logged into the network management system, and which will help authority to maintain the sanctity of that particular region. So likewise, there are many other, like, automatic international maritime boundary crossing alerts. So fishermen, like, our lot of fishermen gets caught by Pakistan and Sri Lanka. So there is a provision where we do the geofencing of international maritime boundary. If they cross that area, they will get an alert, and so that they don't intrude into their fishing area and get caught. So that also feature is built into this system. So another NavCom application, which was like, which was earlier, it was a purely communication application when we launched this service 10 years ago, wherein there was a UHF transmitter which was used by day-going fishermen. They press an emergency button, they face a medical emergency, or some boat catches fire, some boat starts sinking, or somebody is trying to overpower them. So it was a manually activated system where you press a manual button and say that, okay, medical means medical emergency is there. That information used to come through our INSAT satellite, and the receiver was kept at Indian Coast Guard premises. We call it Maritime Rescue Coordination Center. So there was an agency identified in Indian Coast Guard which used to send the rescue team corresponding to the type of needs they have sent it. Earlier, this system didn't have a provision to send the acknowledgement. So fisherman, after pressing emergency, was kept on waiting that okay, somebody will come and rescue me. He didn't knew whether somebody is going to come, whether my message has been received or not. So when we envisaged the NavIC, as Praveen told you, that a special differentiator, one was messaging. So what we have done now is we have removed the earlier GPS receivers into that, and we have enabled it with NavIC system. Where and what has happened is whenever now it transmits that signal, it's received by Maritime Rescue Coordination Center. The acknowledgement message now we are routing through the NavIC messaging server, and that comes through the NavIC messaging channel to our receivers. So the old system we have updated with the NavIC messaging receiver, so that now the acknowledgement also comes into picture now. And this is again, as I said, is we have made it a Bluetooth enabled device. So Android app is there where they get the acknowledgement message. So now the fisherman, when he presses a message, emergency message button, the acknowledgement comes to him and he knows that okay, my message has been received and now somebody is going to come and rescue us. So that has been, this is one of the good improvisation which we could do thanks to our own NavIC system, which has got this feature, messaging feature built into this. So this is again video which was kept. Unfortunately, it will PDF system, it will not display. This is how the system, whole system has been deployed. We have developed a website called Sagar Mitra, which actually provides this is live system 24/7, being accessed by all Maritime Rescue Coordination Centers. And I'm happy to say that many of the lives has been saved. Last year, 23 lives were saved using this system. So these are some of the testimony where they're like, no, people have been able to successfully save life using this system. The one, this is another system where we are trying to do a aircraft tracking. It's the same system, but there was no system existing today in the country to monitor the movement of our aircraft. So a special user approached us, and then we built this system. Again, here it is basically right now we are using NavIC enabled GNSS system, and we wish to in future we'll upgrade it to probably the RS services so that it becomes more reliable, robust navigation system and NavCom system. So here position of the passenger aircraft is being reported every 4 seconds. And this system has been showcased recently in Aeroso at Bangalore. And the system is now getting into implementation. Very soon, this will be inducted in the services. Similarly, we have done a very small system, mobile satellite service system only, which is also NavIC enabled for tracking this our personnel. This is one-way system, wherein like no position of each of these personnel is being reported periodically at using a very small device to a central location, and you can track the personnel. So this is basically for those areas like what you call it is high altitude areas where there is no other means of communication. It can be utilized. This is another NavCom application which we demonstrated to our Indian Army friends. There was a need for battlefield management system, basically for creating situational awareness. So when our tanks they go for in the battlefield, the areas like Rajasthan desert and all, they do not know. They go into a formation. Usually they go into a formation of 17 and 20, like not. There are different formations. The number of tanks go into one formation towards the enemy, and because of the nature of the because of the geography, they do not know their relative positions. So it has happened in the past that our tank was targeting our own tanks. So to avoid such situation, they wanted that each of these tank in the formation should be able to know the relative position of or the position of the other fellow tank members, like no. So what happened is we modified our system that whatever the NavCom system which we have shown you, the two-way system, wherein user can group the position, like no, whatever number of tanks. If you have a 15 tanks, you can group them together in a formation, and their respective positions are received at the control station. regrouped together and rebroadcast, which is being received by each of these tanks. So they know their own position and the position of the group members. That is all made available on a app or Android app, which is fitted into the tank. So they know their relative position. So this system was field tried in Rajasthan, and now very soon it is likely that it will be taken into implementation. So this was again, the system was named Devrakshak at that point of time. It's a suitable NavCom application where each of these assets, they are able to know their own live position together with the relative position of their group members, which helps them in doing the battlefield management. During COVID, there was a requirement that our oxygen tankers, like, they were to be made available. So they approached us. There were certain areas where the terrestrial connectivity was not there. So this system was demonstrated to track this, like, containers they used to go for filling into different plants, and they come and supply at different locations. To do the supply chain management, the Mighty that time approached us, and we demonstrated the services at that point of time. This was done, demonstrated, and it can be taken live as and when required. So these are some of the NavCom applications which was done to popularize this NavIC applications, and you must have seen that some of the applications are very specific to NavIC, like distress alert transmitter with NavIC receiver. So it's a good synergy between the navigation and communication, which has enabled these kind of services. So that's the beauty of indigenization. So if you are able to indigenize both the technologies, the communication and navigation, there are many such unique applications which we can build and popularize. So that's all from my side. If you want to know more about any of the applications or services, do write back to us, and we will be able to provide you more clarification. Thank you for your patient hearing.
Yes.
Hearing.
Thank you, sir. Thank you, Dr. Chandraprakash, sir. If you all have any questions, please, just I want to inform that question answer session is in last. So in last, let's do write your questions. We will take all the questions in last. So next, I will invite third speaker, Sri Kalpesh ji. Sri Kalpesh ji is scientist F at SAC ISRO Ahmedabad only. He is working with SAC for last 15 years in the field of satellite navigation and its applications. His key contributions are in the design in the design and realization of NavIC and GNSS receivers for various applications like location tracking, launch vehicles, messaging, timing, and high frequency positioning. His major working areas are satellite navigation, signal processing, FPGA, and embedded systems. Over to you, Kalpesh ji, please proceed.
Thank you, Subhash ji, for nice introduction. Actually, previous speakers have covered many of the applications. So here, generic GNSS applications I will be talking about, and some special applications developed for NavIC receivers. Those also I will be covering. So this is basic principle of the satellite navigation that is well known to everybody, I think, that using 3 satellites or known location, measuring the distance to 3 known locations can give you your location. But as Director Sir also pointed out, that in receivers we have a lower quality clock, so which tends to drift and develop some bias. So we need the 4th measurement as well. So using any navigation receiver, we can get position, velocity, and the time information. So you can tune your clocks and synchronize your clocks to the navigation system times, which are maintained by highly stable clocks, atomic clocks, and you can have a stable time information and utilize those time for your day-to-day activities or any other time measurements related applications. So these are, as I discussed, these are some of the outputs. Like a standard GNSS receiver, a standalone receiver can give you about 5 to 10 meter accurate position. Then we can have some techniques to improve this position to millimeter, centimeter, or decimeter level, and accordingly we can have some high accuracy applications. Then besides knowing the position, there can be some safety of life applications where we need the integrity of those positions. So there are some differential processing and even this augmentation services which can provide you the integrity of the solution, whether the solution is useful or not, or whether some satellites are useful in deriving this position solution or not. Then of course all these navigation systems, Genesis is basically the defense requirements, right? These civilian applications are actually byproduct of these navigation systems. So these systems have their restricted services or encrypted signals for such applications which are targeted for defense or strategic applications. Now, as I mentioned that this GNSS system can provide you a very accurate time. And you even using standard receivers, you can get accuracy of the order of 10 nanosecond. And besides that, a very stable time, as sir mentioned earlier also, that this stability of this time can be of the order of 1 second in millions of years. When you compare with our standard oscillators, crystal-based oscillators, which are in our clocks, they drift about a second in a day. So you can think of the stability of this, the timing signals available from these receivers. And that's how they provide us a low-cost access to precise and stable time when compared to owning an atomic clock in our premises. And besides that, as these signals are affected by some atmospheric parameters, so those signals can be used to study some atmospheric or weather-related phenomena, which can be helpful in some weather predictions as well as the effect of these weather parameters or space weather parameters in particular on various technological systems on the Earth. Yeah, so here, these images are basically symbolic. Okay, so yeah, so as I mentioned that we have position and navigation information. So using those information, we can have various applications in the navigation or vehicular navigation or transportation. Like in personal and vehicle navigation, we can use those for tracking or routing of the fleet and scheduling of various vehicles. Then in intelligent transport system and some safety and security related applications. Particularly, you might be aware about this government mandate on using these tracking systems in public transport in order to avoid some unfortunate incidents after that Nirvaya incident. Then this was also discussed like train fleet management and train collision avoidance, where besides position information, they also need integrity of those position information. That's like if you are giving some position to within, let's say, 5 meter or 10 meter accuracy, then it should also show me that this position, whatever I'm estimating, is correct, because otherwise it may lead to some collision or unfortunate incidents. Yeah, and besides that, this boat and ship navigation again for coastal surveillance and efficiency of the boat owners in going for these catchments, fish catchments and all those things. Then in different phases of flight, right now, these aircrafts, particularly the civilian aircrafts, they use localized that instrumentation landing systems for precision landing approaches. So international, this civil aviation organization, they have now mandated use of satellite-based navigation. Of course, aided by this wide area augmentation system, the way we have that Gagan-based system for such augmentation, and they have mandated use of this system for en route as well as some precision approaches, thereby leading to saving of the fuel and efficient routing of these aircrafts and better tracking of the aircraft. And they can be placed closely by using such high accuracy systems, and we can improve the aircraft operation efficiencies. And of course, this robotics and the instruments used in various industrial establishment. So there, these navigation systems are used for these autonomous or robotic equipments. And in the commercial drones, let's say for photography, then some remote sensing drones are also there. Then nowadays, no delivery of the material to the customers. There also this drone is being used. So all these require a precise position, and that too, across the globe, because a localized system will have a limited service volume here, because it's satellite based. The availability is ensured in even in the remote areas. Yeah, yes, and in the agriculture, where the showing or precision agriculture, the tractors and all these agriculture equipments, they also now rely on these navigation systems. And yes, well-known application, which is in fact known to everybody, that GIS users, geographic information system. So we all know use this GPS-based. In fact, GPS has become synonymous with satellite navigation system. Though in mobile it might be using the combination of all available satellites, right? But still we call it GPS. So this helps in some of the GIS applications, like visiting some places of interest, that, reviewing the selection of those places, geotagging of various places, management of natural and other land resources or archaeological monuments, then land surveying. Of course, in surveying we need very high accuracy. The way I mentioned, for high accuracy there are some techniques like differential processing or RTK or PPP techniques. So they are used in these land surveying applications. Then forest mensuration, then town planning, also in the construction of various utilities or buildings, where we need to identify the required area for the development or the required patches of the land. All these requires very high accuracy positioning outputs. So there these satellite-based navigation systems are nowadays being used, which were earlier some conventional systems were used, like theodolite and all those things, where we need which were not that efficient. Here a single GNSS receiver can serve the purpose, where we earlier using conventional systems, we need some 2-3 persons to be engaged in such activities. Right? Then the topographic surveys, yes, regarding this, the different utilities, buildings of forest and all those things, and defining the boundaries or ownership of the land. Like creating the cadastral map, where the different parcels of land and their ownerships are defined. Then various drainage and the roads and all these infrastructure, their locations with respect to such establishments, those needs to be defined. So there such a surveying grade, these GNSS receivers are being used. And then of course in disaster management, where the location of the disaster affected areas, like landslide, floods, earthquake or cyclone, those can be identified and people can be informed about such incidents in given areas. Then geofencing of such disaster affected areas to manage this disaster affected places, and to route the public accordingly and minimize the damage. And the search and rescue operations, where management of the equipments used in this search and rescue, they can be using these navigation equipments or navigation receivers to identify and better manage their responses to the such disasters. Then agriculture, where the precision or the accurate positioning is required. So there this differential processing, where the use of 2 receivers can achieve a very high grade of accuracy of the order of centimeter level. So such applications are there in the agriculture sector as well. Also geotagging of the soil samples to better analyze the soil suitability for different types of crops and all the irrigation requirements. All these need the geotagging or geo location information. So there this GNSS finds its application. Of course, in showing or applying fertilizers by using the tractors or land vehicles, as well as the drones nowadays. So all these require precise this information about their location to identify the patches of land where the particular activity needs to be carried out. Yeah, of course, the strategic application, the main application for which these systems are developed. So they use these restricted services or encrypted services, which are not open to the general public, and these signals are having better performance with respect to the jamming or spoofing requirements. So there, mines detection, laying, then battlefield management like troops formation, and the management of the artilleries and weapons, then bombs and missile guidance, and guns, mortar, all these weapons, navigation of these weapons using this GNSS is being done. Then of course military drone control and navigation, then military aircrafts, the way Chandra Prakash sir also mentioned about that, military aircraft tracking, then ship and submarine navigation. Then of course this defense uses secured radio networks. So there also this time and frequency synchronization using GNSS based systems finds its application. In the space exploration, of course, for this rocket or launch vehicle tracking, then re-entry and landing of the space mission, plus the spacecraft tracking, in orbit tracking. Also, they have their space qualified these GNSS receivers. And while launching a precise orbit, determining the precise orbit of the satellite and precise velocity of the in that orbit. For that also these high dynamics receivers are being GNSS receivers are being used, and of course georeferencing of the remote sensing satellite data. For that also we need this location information, and this GNSS plays a very important role there. Plus the satellite earth stations which are spread throughout large geographic area. There they need to synchronize all these earth stations, and they need to generate precise time and the precise frequencies corresponding to the satellite transmit frequencies or time slots. So there also these GNSS systems are now used for such time and frequency references. Of course, not very known application, but this is a very important application, particularly in the electric power grid, where this power generation is happening at different places, then they are combined and distributed to the user. All these systems, not these power plants, distribution systems, they are spread across very large geographical areas, and this power needs to be combined to one power distribution at one power distribution systems. The power generated from different sources, all this needs to be combined at one source and being needs to be distributed to the users. And there will be different load requirements during different in different parts of that geographic area at the same time during different seasons and different time of the day. So all these need a precise measurement of various power parameters, power generation parameters. We call it the phasor measurements. That's nothing but the voltage and current phasors of the power system, like 230 or 220 volt 50 hertz system. So this needs to be precisely measured at all these locations at the same time. Of course, you can do it by having the stable atomic clocks at all these locations, but that will be a very costly solution. So GNSS provides a precise time and precise time synchronization as well. So using these GNSS receivers in these systems give us access, help us in monitoring these parameters simultaneously with better accuracy, and those can be used to better control and monitor these power systems, to combine power generated from different sources into one distribution line, and also in the fault location and fault identification of any fault happening in these transmission lines. It can be identified by measuring the artifacts or whatever standing wave or reflected waves generated out of such power line faults, and measuring the travel time of those waves can help us identify the location of those faults, and it can help us in faster repair of such faults, and of course which helps us in improving the efficiency of these power systems. And besides that, the computers or other systems being used in these systems also needs to be synchronized. So computer data networks also are being synchronized using GNSS based timings or GNSS based network time servers. Yeah, in data and communication network, of course, the details will be covered by the subsequent speaker. But this finds its application in satellite communication, wireless telephone, and data networks, where precise time and frequency references and frequency synchronization is essential. There also these GNSS based references are used, which helps us in better management of the available resources, frequency resources, and time resources, particularly in the this TDD and FDD kind of transmissions. And in the communication network, of course, the management of the servers, management of the various transactions happening on the data networks, computer networks, or the financial networks, where time tagging of all these transactions, maintaining these logs helps us in better management of the network, troubleshooting or identifying any network failures, and also the validating or auditing purpose of various financial time transactions. Here in the data communication network, generally this time synchronization or node synchronization is done using the network time protocol, which is a ubiquitous protocol being used in these computer networks, where we can get a millisecond level time synchronization accuracy. Again, this NTP will have a grandmaster clock, which will be reference to the GNSS time or GNSS receiver, and that will be distributing this time in the downline these computer networks. And in the industrial automation, where high accuracy time synchronization is required, like automation of this robotic equipments used in these industrial industrial establishments, there defined protocol known as precise time protocol, which can provide accuracy of the order of microseconds. Such protocols are used in such small area networks for industrial this automation and control. Yeah. Other scientific applications, like as I mentioned, that this GNSS can provide time stability of the order of atomic standard. So this can be used as a measurement or a reference for calibration or measurement of other equipments within the laboratories, which can be distributed across various geographic locations. Plus, using the GNSS reference, we can generate, we call it GNSS disciplined oscillator, which can generate very stable reference of the, and which can give the stability of the order of 10 raised to minus 12, and this can be used as the frequency standard in laboratory instruments. And besides this, this seismic monitoring networks, having seismographs located at different locations to identify the epicenter and the earthquake related other parameters. So they needs to be synchronized to as least or as lower the time difference between them as possible. So they also use this GNSS based receivers. And of course, for time synchronization between different timekeeping laboratories, like the NPL of India is keeping our IST or our version of UTC. So such laboratories also utilize this GNSS receiver in the common view techniques. Then measuring the Earth gravity field, they're using some airborne equipments, gravimetry equipments. They also utilize this GNSS based receivers. Then measuring ocean levels, then other topographic features, then crustal movements or deformations of tectonic plates. All these require very high accuracy GNSS receivers. So there are various network of these GNSS receivers for such high accuracy applications, and they are continuously monitoring these topographic or crustal movements. Also for various, not only for societal but also for scientific applications, and contributing to this, some geo models, geodynamics models. Of course, this, as I mentioned, that this signals passes through this atmosphere. So it affects these signals also. This content of this atmosphere, particularly this ionosphere, which contains charged particles. So they have different what you call refractive index compared to the vacuum. So these delays or band these signals, and those can be no delays and the advancement or delay of this phase of these signals can be used to study this atmospheric content and what to call this ocean study. Here again, these signals, when they are reflected from the surface, they can also be used. These reflected signals can also be used to identify various features of ocean or the soil. So that is the separate field known as GNSS reflectometry, where reflected signals can be captured by the airborne or ground-based application, ground-based systems or receivers, and also some satellite-based systems. And this can be further analyzed to identify various soil moisture content or sea levels and ice cover related parameters. Then in ocean study, there are different buoys, we call it floating equipments. They are placed in these oceans or near coastal areas to study various parameters like high wave or the tsunami related predictions or rip currents, so that the fishermen or the people can be warned of such events or hazardous events. There also the GNSS receivers are being used. Then studying the atmospheric profile like humidity, pressure, wind profiles for weather prediction. So there also this the different applications like radio sonde devices are being used. Also the tropospheric delays can be measured using this GNSS receiver. And the ionospheric modeling, that ionospheric content of this, or rather electronic content in the ionosphere, which is affected by various space weather phenomena like solar flares or sunspot or geothermal cycles. So these variations can be measured by these GNSS receivers by analyzing the signals from these GNSS satellites. So they can be useful in this space weather studies or scintillation studies, which can be helpful in modeling this ionosphere and also predicting or assessing the impact of these such phenomena, space weather phenomena, on various technological systems on the Earth, like telecommunication system, power grid, and other systems. Then this radio occultation again for the atmospheric profiling, where these radio signals gets bent by this atmosphere, and those can be used to study the atmosphere. Yeah. And now coming to this NavIC, as I mentioned, all these applications, they apply also to this NavIC, because NavIC is also in providing this navigation signals. So we have developed some of the systems using this NavIC, and they are being used in ISRO as well as by some other organization in the country. So this is one of the system where we have developed this. Of course, again, it is Make in India, where this complete design and development is taken. Design is done by the ISRO, and the development or fabrication of the hardware was done by the Indian industry. So this is one such system. The government has mandated using this NavIC-based tracker or the tracking system, in particular in the public transport. They have standardized even the complete system by a standard known as AIS, Automotive Industry Standard 140 by Ministry of Road Transport. Okay, and this is one such system which the image here shows tracking of one of our payload convoy being transported to Bengaluru. So here the device which will be sending this location data and other alert related data through internet or using the cellular network to our control server, which is located at site. In power grid, we have provided some timing receivers in power grid, and just to assess its performance across Indian or across its service area, we have installed such power the NavIC-based timing receivers in different parts of the country in power grid. And here you can see those locations which are spread in 5 different corners of the country. They are having dual frequency, as previously mentioned by Praveen, that using dual frequency can give you a better accuracy. So this will be providing a better timing accuracy, and of course they have some standard. There is an international standard for communicating this time known as IRIG standard. So they are giving this timing information in IRIG output, and they'll become providing this to the measurement units installed in these power systems. And you can see here they are well matching. No, all these measurements are in sync despite their location in different parts of the country. Yeah. Then this NavIC-based time server. So this NavIC-based time is also fed to one of the NTP server which we have established here, which is providing this NavIC time to not only to the ISRO centers but also to the railway information system, that is CRIS. They are also taking this network time, rather the time from this our network server. Then it's being used for synchronization of all ISRO centers, also time stamping of the remote sensing satellite data. And besides that, it also has this discipline 10 megahertz output, where high accuracy output can be used for different as a reference for different instruments. These are some of the places where also we are using this NavIC receiver to display the time. Some national premises. This is at the ISRO, and then in the Science City, and of course it can be used at other places like railway station or at the airports. So well, here this is showing the link to this network time server. So that's there on our SEC website. You can see this time of this network time server, which is based on the IRNSS network time. Yeah, the message NavIC-based messaging service, as mentioned earlier, that some of the satellites which are not now suitable for this navigation applications are now steered for this messaging. 1A and 1G are dedicated for such service. Here, as mentioned in previous the talk as well, that authenticated user can register on our this INC. INC has developed such software so that these users can register on that. They can send their data, or they can also have a mutual understanding on the format of the data. That data can be sent to over this INC, and they can via our uplink station uplink to the IMSS satellites, and which can be transmitted to the defined user. This user can be any agency or any private user as well. As discussed earlier, also it can provide position solution along with the short text messages. Also it can be used for message authentication and providing the message alerts in case of disaster, and also to also used for sending the advisory messages, particularly for the to the fishermen where no other channel of communication is available. And of course, the geofencing related to the international boundaries, so that they can be warned of crossing international boundaries. And as mentioned by in the previous talk, that two-way communication in conjunction with the satellite terminals can also open up a new domain of the application. Yeah, this is one such this experiment which we carried out with the Kerala government, where this potential fishing zone related information which was generated by INCOIS, and along with other alerts like cyclone or high wave alerts, this information was sent to our ISRO Navigation Center, and it's being transmitted through this IRNSS 1A satellites to fishermen. And these receivers are developed. The proto version was developed in SEC, and of course the technology is transferred to some more than 8 vendors, and they are developing these receivers and distributing to fishermen for such information or such alerts. These have audio-visual indications related to various alerts and what you call the fishing zones, so that fishermen can efficiently, at a lower fuel cost, they can reach to such high fishing or high yield locations in the sea. Another is related to this Aadhaar enrollment center, in order to avoid some malpractices of this Aadhaar, the fake Aadhaars getting generated even in outside the country. So they have asked for geo and time tagging of these Aadhaar centers. So in pilot phase, we provided some receivers. These are Bluetooth enabled receivers, based on NavIC, and they can be used to geotag those Aadhaar centers. And now the MeitY has taken up this project further to install around 1 lakh such units in their Aadhaar tech centers. And for the this space exploration, as I mentioned, in our launchers, we have this NavIC-based receivers to track and to determine the or precise orbit determination of the newly launched satellites. We have such ruggedized receivers which are installed in these launchers and used for such these applications tracking as well as precise orbit determination. Then for ocean and atmospheric studies, as I mentioned, that buoy or drifters, floating buoy or drifter developed by ISRO and are used by various the ocean-related authorities. Sorry, yeah. And for this upper atmospheric studies required for Indian Meteorological Department and also for the rocket launching, they are using this radio sonde equipments. There also we have miniaturized, some 3 by 3 centimeter devices, NavIC receiver devices, which have inbuilt antenna are being used. Then, of course, for drone tracking, this is one such drone being used by our Northeast Remote Sensing Center, Northeast Space Application Center, rather, for remote sensing applications. There also we have such receivers, and these are some of the trials done with those receivers. Then we are also developing receivers for this atmospheric studies and remote sensing. That is for this NavIC-based reflectometry, because it also provides observations in S-band, where other GNSS systems are only in the L-band. We also have signals in S-band, so that will give added information, or rather better information regarding this parameters, reflectometry parameters. Then this is for the scintillation monitoring, or TEC, total electron content monitoring of the ionosphere activities. So there we have developed these algorithms and receivers here. Then for high accuracy applications like surveying or mapping or precision agriculture kind of applications, where we need to have differential processing, that also we are working on this differential NavIC related application. We have developed this differential carrier phase based receivers, where we have one base receiver installed at a known location, which can transmit these corrections to a receiver in the field known as the rover receiver, and we can obtain a centimeter level accuracy. Here you can see the accuracies are almost comparable with the GPS. At the same time, as Director Sir has mentioned earlier, now the standard is to use all in view, that is all GNSS satellites. So of course NavIC is aiding them by improving their accuracy and availability. And as mentioned in previous talks, that NavIC is in the geo orbit, so it will be always visible, and at the same time it improves a kind of dilution of precision factor, which we call in GNSS terminology, and which helps us in obtaining better accuracy. So that we have developed here these algorithms and technology in-house. We are using it for our calibration of our remote sensing satellites, and of course we are targeting it for application in the course network being established by Survey of India as well as some state authorities for their land surveys carried out by the revenue departments. And of course, in the future, network RTK related service and PPP related services. This was anyway discussed that in conjunction with the satellite communication, there can be a host of applications. So these applications are anyway discussed. These are some of the receivers which starting from this tabletop receiver with FPGA-based receivers. Now receivers, of course, Indian industry have also developed some receivers initially for this study of the NavIC signals. And now this has also come in the low power and small form factor. These are some of the chipsets developed by Indian as well as the foreign vendors, which have NavIC inside their chipsets. This is one of the chip which is developed in-house, and of course now it is part of the many of the mobile-based chipset as well. And these are small form factor chips which are used in various IoT or wearable applications. Here you can see 5 x 5 mm, and also Sony has developed one 3.7 by 3.2 mm chipset, particularly targeting the wearable or low power application the power is as low as 30 to 35 milliwatt. And of course, this also is known to most of you that NavIC has also now come in mobile phones. Various chipset manufacturers like Broadcom, Qualcomm, MediaTek, they have included NavIC in their chipsets. So the mobile sets having these chipsets now can receive NavIC signals, and of course, which will aid in having better accuracy and better availability of the positioning services. These are some of the devices. This is actually a bit older slide. Now maybe there are many devices having this NavIC in them. Okay, so I'll be concluding with that. Thank you. You can take a few questions if any.
Thank you, Kalpeji. Thank you for very detailed presentation. If anyone, if any audience have any question, you may please ask. Otherwise, we'll have a dedicated question answer session in last. So we'll take question in last. Okay. So let me invite our next speaker, Sri Niskam Jain ji. He is a scientist F in SAC ISRO Ahmedabad. He joined SAC in 2005. He is ME in signal processing from Indian Institute of Science, Bangalore. He is currently working as a scientist staff at Navigation Application Division, Space Application Center, Ahmedabad only. His team has developed the first NavIC receiver in SAC. He is involved in the development of evaluation of various NavIC and GNSS applications developed in SAC and by Indian industries and startups. His research interests are precise positioning using pseudo range and carrier phase, receiver clock steering, real-time kinematics data processing, and novel navigation application developments. Over to you, Niskamji. Please proceed.
Thank you, Subhash. Thank you for the opportunity. I hope the slides are visible.
Yes, very well. Please go ahead.
Yeah, so I welcome you all. Today's topic is GNSS applications for telecom. That is your domain. So the overview of the talk is divided in these sections. First, all the GNSS applications for telecom, where all in telecom sector the GNSS can be used, and the upcoming applications like telecom network synchronization, assisted GNSS, some flavor of location-based services, emergency location reporting. Apart from that, the telecom standards for assisted NavIC, where NavIC stands today, and the future telecom, where it is going in the future. So this is an overview of all the GNSS constellations that are available today. When we say multi-constellation, that means a receiver which is capable of working with multiple constellations. Like we have global constellations, GPS from US, Galileo from Europe, GLONASS from Russia, BeiDou from China. These are global ones. And these are the multiple, when we say multiple frequency, these are the frequency bands where these signals are being transmitted. Similarly, we have regional constellations like QZSS from Japan and our own NavIC from India, where it is currently transmitting in L5 and S-band, and as Praveen told, shortly in L1 band also. So GNSS is the backbone of telecom network synchronization. Most of the people think that GNSS will provide you position, velocity, navigation, but timing is also one of the byproduct, and that is extensively used in your telecom sector. The GNSS satellites provide you accurate timestamps, and that is being provided to a grandmaster clock. And further, with a network of boundary clocks and the end clocks, it is being distributed through the telecom network to the base stations level. So this synchronization quality must be confirmed at every cell site, and this is essential for any telecom operation. So this is an example of PTP network. Industry standards are like SYNC-key, NTP, PTP. So SYNC-key is like synchronous Ethernet. So where all three standards are used for digital synchronization of networks. So in synchronous Ethernet, you have a primary reference timing clock, which is being synchronized by a GNSS receiver. And there are a host of synchronization supply units and synchronous equipment clocks. Then NTP, network time protocol, where you have a level of servers, basically a server client hierarchy, and mostly Stratum 1 servers are connected to the GNSS receiver for synchronization. Finally, synchronizing the user equipment. And the most accurate one, the PTP, like the precision time protocol, which is a master-slave clock hierarchy, where GNSS receivers are synchronizing the primary reference timing clocks, then the grandmaster clocks, then boundary clocks, and then finally the time slaves clocks, which are at the end like your master switching centers, MSC, and the BSS, base stations. So mostly NTP and PTP is widely used. NTP is lower in accuracy, PTP is more in accuracy. NTP accuracy is of the order of microseconds. PTP is of the NTP is of the order of milli to microseconds, and PTP of the order of micro to nanoseconds. So in as everybody talks about telecom, in 4G, the requirement is of the order of 1.5 microsecond synchronization for your networks. And the first level of 5G, the requirements are even higher. It is of the order of 130 nanoseconds for synchronization. And for the second phase of 5G, it will be even higher, 65 nanoseconds for synchronization. So such type of a high level of synchronization is required, which is provided by PTP. So these are all the summary of all the type of devices that are available in timing microsegment for synchronization, starting from chips to modules to OEM boards to standard slots, package systems, and modular systems. So mostly in telecom sector, standard slot, package system, and modular systems are being used, which are typically in either rack mounted, chassis mounted, 100+ channels. And here you see multi-constellation. So now trend is to go for multi-constellations and multi-frequency. So primarily there will be single L1 frequency, which is GPS in all of the devices. And apart from them, multi-frequency and multi-constellation support is also being now provided. So then most of the accuracy is still critical here, and interface and protocols influence the performance of the overall network. So you see like the requirement is basically for a protocol, like some are sync key supported, some are PTP and NTP supported, and there is an OCXO or TCXO to provide a good holdover accuracy for your devices. And all of these devices and the future devices which are being made are now being equipped with time receiver autonomous integrity monitoring, or TRAM feature, and interference monitoring features. As mentioned in the previous, like spoofing is a real threat for this segment. So all those features are being built up in this segment. Now NavIC based time, now where we fit in, NavIC based time and frequency synchronization. Like GNSS, any GNSS can provide you time and frequency synchronization. So we have developed NavIC based products. NavIC provides you basically synchronized to NavIC system time, which is the time source of NavIC, and which is traceable to UTC time, which is synchronized to universally coordinated time. So all your assets, base stations, you can have traceability to UTC time when you synchronize with NavIC. These are some of the timing receivers which are used in power sector for synchronization of power grids, ATM and banking networks, for time stamping financial transactions, LAN and mobile networks. Similarly, this can also be used in your telecom sector. So they can provide very good timing accuracy of the order of nanoseconds, and it is then for the protocols which are being used. Then we have provided this in power grid synchronization. We have provided this to railways, as sir mentioned. The RTIS network is synchronized to NavIC time. Then MOSDAC is and IIT Kanpur are synchronized to NavIC time, and ISRO's SHAR operations, whenever a launch takes place, they are all synchronized to NavIC system time. This is a screenshot for today, just before the presentation, where you also can go to ISRO's website. You can click on NavIC time, and the current time is being displayed. and the Chris is using the time from these servers. This is the screenshot of a NavIC timing receiver. The white one is the NavIC timing receiver, and the below one, the rack mounted, is the NTP server, which is used to synchronize our SAC network. Apart from synchronization, one more application has come up, which is of assisted GNSS system. So traditionally, a receiver downloads the data from the GPS or GNSS satellites. But due to urban canyons or any multipath, if there are signal fractures, then this is the concept where alternatively you can provide assistance data or information from your terrestrial network, which are the base stations or the cellular network. So what kind of assistance? Like almanac, ephemeris, frequency, time, and position assistance. So this assistance can be provided to the mobile phone. What are the advantages? The mobile phone will know what frequencies to expect even before it tries, and the satellite positions or the ephemeris data will be available. So the advantage straight away will be in TTFF. The TTFF can be reduced of the order of minutes to seconds, and it allows to acquire signals at a very fast rate. So this is the concept of assisted GNSS systems. And along with the assisted GNSS, where the assistant information is provided to the AGPS user or the handset, you can see there is a back arrow also. So this back information is basically the user position, which is provided back to the base stations and then the mobile switching centers, and finally to the AGPS server. So the server knows where you are. So basically that gives a plethora of new applications like emergency services and location content providers. So once they have access to your location, they can give you additional services. Now, two methods are used in mobile stations, basically MS assisted and MS based. In mobile stations assisted, basically the acquisition assistance from the server to the mobile station is provided, and then the raw measurements are provided back to the servers. So the final position is computed at the server itself. So all the users will provide this information, and the server finally computes the position of each and every mobile phone. In the second technique or the method, MS based, mobile station based, basically the position is computed at the mobile phone itself. So only time, position, ephemeris is provided, and finally the position is computed at the user end, and that position and time velocity will be provided back to the server. So the take home lesson is either you use MS assisted based in telecom or you use MS based. In both of these, your position is available to the server. Now here, some of the places it has been mandated also. Like there is a government mandate for emergency call from mobile phones in the US. So you have 911 or enhanced 911 mandated by the FCC. So they mandate that the position of the phone to be provided when an emergency call is made. So for landline phones, the locations are maintained in a database, but for wireless phone, in phase 1, the carrier has the responsibility to provide the phone number and the location of the call site from the base station where the call is being connected. And in the phase 2, you can see there is even more requirement. The carrier must provide the location, the latitude and longitude of the phone itself. And the accuracy ranges from 50 to 300 meter based on the technologies. Which technologies are either you are using? You are using GPS or you are using terrestrial location technologies or geolocation technologies. So based on these technologies, these accuracy requirement change. Similar mandate is there in Europe. E112 in Europe has been mandated. Similar mandate is in Japan. So time is not far when, like in 108 today, we use XOAT for calling emergency. And it is basically a call center based application where there is an accident. The ambulance, you call 108 and an ambulance will be dispatched. And the location and all is reported manually where you are and like that. So time will not be far when the government mandates this in future. And this type of an emergency location is available in the 108 services. Now, this is a simple call flow between a server, a base station, and a mobile station. So this call flow, since there are different network operators, so many network operators are there. so many mobile manufacturers are there, different handsets are there. So there has to be some protocol which defines how the assistance data will be delivered, how the position request queries will be made, how the position response will be there. So all these things is basically defined in AGPS standards, which define the sequence of events, call flows, and it contains the positioning method, which positioning method you are using. Either you are using GPS, GNSS, or you are using terrestrial location based or geolocation based strategies. Which method type, either mobile station assisted or mobile station based you are using. Then location request procedures, whether a location based service app has requested your position or whether the law enforcement authorities have requested your position. So procedures are different for both. Similarly, when your mobile phone is asking location content from the location content provider. So for catering to all those aspects, there is a need for standard. Now, as we see the evaluation of telecom from 1G to 5G, 3G covers UMTS, 4G covers LTE, and now 5G. So definitely the data or the internet connectivity and all these services are increasing. So all this has been, there is a need for standards for all this. So GSM, UMTS, LTE fall in the 3GPP, or the third generation partnership project. So this 3GPP defines these standards, and CDMA falls in 3GPP2 family. In 3GPP, you have two groups. One is the GRAN group for GSM and RAN group for UMTS and LTE. So basically, the RAN group defines the standards for 5G. Now, there are two different standardization bodies, the 3GPP and OMA. So 3GPP defines the standards for GSM, UMTS, LTE, CDMA, whilst the OMA defines the user plane standards. Now in 3GPP, the RRLP defines the standards for GSM, TIA defines the standards for CDMA, and RRC defines the standards for UMTS networks. For 5G, which is upcoming in India, the LPP or local positioning protocols are defined. Similarly, you have for user plane protocol, these are all control plane protocol or basically circuit switch networks. But for the packet switch networks, the SUPL protocol is defined by the OMA. So these are all the host of telecom standards applicable. Now it's a small comparison of all the location technologies. So you can see the hybrid or AGPS based technologies where you are using assisted GPS, as well as the hybrid geolocation technologies give you the best accuracy possible. And apart from the other geolocation technologies. So these are compatible to all the networks, and these are the location protocols that are supporting these location technologies. Now I'm happy to state that now NavIC is included in 3GPP. So NavIC has become part of the latest specifications of 3GPP for assisted GNSS. So now the time is not far when you will see assisted NavIC in mobile phones. So NavIC has been incorporated in 3GPP release 16 standards, and this will ensure common denominator performance for NavIC assistance among various telecom service providers. And now NavIC can also reap the benefits of assisted GNSS. So this is the 3GPP standard. As I told you, RAN group, technical specification, radio access network. RAN group is responsible. So we, along with our supporters like Reliance Jio also participated in this. We approached the RAN group, which issued this LTE positioning LPP protocol. This exercise started in release 15, and finally in release 16, you can see NavIC has been included for assisted GNSS. So in release 16, and in India, the Telecom Standard Development Society of India, the TSDSI, is the main agency and which has adopted these specifications as an Indian telecom standard. So if you go to TSDSI website, so you can see there is 3GPP release 16. So that was released in September last year, and all these specifications support NavIC. So assisted NavIC is included in the release 16 standard by TSDSI and 3GPP. Now, even after that, release 17 has come up. So release 17 also includes newer features in telecom domain. Now, NavIC in smartphones. So there are basically in this segment, there are three major players: Qualcomm, Broadcom, and MediaTek. And Qualcomm captures 80% of the mobile phone chip market. So these chips are costing less than 30 cents, and they include everything like processor, GNSS, Bluetooth, Wi-Fi, FM radio, everything is included in a single chip. So now NavIC is included in all these Broadcom. I'm happy to state that all the three major players, Qualcomm, Broadcom, and MediaTek, have now products which are supporting NavIC. The list is there for you to see, and it is also available in these smartphones. If you see Qualcomm has released 3 series, 460, 662, and 720G. So catering to the low segment, medium segment, and high segment. So in these mobile Snapdragon processors, NavIC is supported, and using these chipsets, there are products like Redmi Note 9 Pro. Similarly, for 5G phones, in 750G is the processor by Qualcomm, and the compatible mobile using this processor, for example, is Xiaomi Mi 10i. So all these have support for NavIC. So in the market now, there are more than 30 such products by manufacturers which support NavIC. So first is, you can see, is the Qualcomm Snapdragon range for low segment, high segment, mid range. Then MediaTek Dimensity, these processors. Then UI, and then Samsung. So all these processors support now NavIC. This is the list of few of the mobile phones available in market that support NavIC. This is the screenshot of the first smartphone that we came across, which was the Mi8. This was the first smartphone supporting NavIC based on the Broadcom BCM dual frequency chipset. And this is our SAC, and you can see this is the location of our building on this smartphone. This is the 6 satellites of NavIC at that time were visible. Now, a mobile phone is not only GNSS, but it's a host, it's a wealth of sensors. You have 3G, 4G, 5G connectivity, you have accelerometer, gyroscope, magnetometer, light sensor, Bluetooth, cameras, whatnot. So all this is available in smartphones nowadays, and this gives rise to a host of location-based services, which is another application. And it is estimated that the 5G network will be required to estimate the position within a range of 10 meters to support all these location-based services and emergency calls in the future. So what are location-based services? Location-based services are basically the delivery of information services where the content of services is tailored to your location or the location of the users. And you see the LBS market. So there is a CAGR of 22% reported by worldwide, that this market is growing exponentially. And you have so much new apps coming up for location-based services. I've listed few of them. Like for navigation and mapping, you have Google Maps, Waze, MapMe, Mapstead, etc. Similarly, location tracking, safety apps, then check-in and review apps, banking apps, e-commerce location apps, advertising apps, shipping and delivery apps, cab hire, weather apps, dating apps, fitness, healthcare, traveler-friendly like public transport tracking, social networking, event app, augmented reality, video sharing apps, and meeting apps. So you name the app, everybody is using your location. Without location, these apps cannot function. They basically, the location is the backbone for functioning of these apps. And how it works, like you have in a mobile phone, there is a setting. So that setting, your location settings is on. So below that, you can see all the services which are using your application. And anytime a new app is installed, it asks for these permissions. So you can enable or disable. And even after that, there are some emergency services, even if you turn it off, they can track your location through geolocation techniques. And you can see these are the AGPS settings. So this is the server address where the AGPS server of your base station, where it is connected to and deriving all the AGPS corrections. Similarly, you can turn them off also. For privacy, you can turn your location services off, but then you won't be able to get the advantage of location-based services. Still in the market, there are 1,000+ apps that track your location without asking for your permission. For example, AccuWeather was one of them, and it has to upgrade to a newer version to solve this problem. Now, these are some of the NavIC based LBS apps for mobile that we have developed. One is the NavIC messaging receiver, which gives informations like there is a high wave alert from so and so place to so and so place at this time of the hours. So fishermen are advised not to venture into the sea. Similarly, positioning and other apps. So these are the apps developed at SAC. Then this is one interesting app, a solar calculator Android app developed by SAC. So which gives you basically at your location, it gives you the solar visibility or your solar insulation. So how much solar power you can generate at your location. So based on that, you can install solar power plants and all those things. So this has been provided to Africa. So this is the screenshot where the Android app as part of International Solar Allowance was provided by the Power Minister to the for solar app for Africa. So NavIC is now included in not only in telecom but all these standards for transportation, as Kalpesh mentioned in AIS 140 for UAV, for telecom, as I told you, 3GPP Reliance 16 version for assisted NavIC is released now. Then for differential, it's part of RTCM in L5 as well as the S-band. In interfaces like NME and RINEX, it is included. It is included in IMO and it is certified for navigation in ocean waters. In maritime, it has been included and recently this standard for NavIC receiver equipment for maritime has been published by IEC, and the others like UAV, ICAO and CORS PPP, they are in process. Now, what's in future? In future, where do we go from here? Like I mentioned, in Reliance release 17 is being also released. So that talks about 5G from space. So 3GPP NTN is the standard for the non-terrestrial networks. So this screenshot is of iPhone 14. So this is the feature now available in iPhone 14. It is currently limited to US only, but very soon it will be launched globally. So where if you are outdoors, you are at a remote place, there is no terrestrial connectivity, no towers, then also you can report your emergency. So that emergency is reported. You have to point to the satellite. In the case of iPhone, it is Global Star, and you can get connected and your location is transmitted directly to the satellite. So this is the latest standards which is available in release 17, which offers support for 3GPP NTN services. So how does it work? Basically, you are at a location where there is no towers. So now your phone is sending data to non-terrestrial networks. This non-terrestrial networks could be either LEO satellites, GEO satellites, or high altitude platform stations like HIBs. So the position is reported to the satellite that goes to the ground station and then further to the base stations. So it can be sent across, even without the terrestrial connectivity over mountains, desert, in the middle of the ocean. And it basically eliminates communication blind spot. So 5G NTN is the latest technology offering direct communication between smartphones and satellites. And two-way messaging as well as image and video is also there. So IoT NTN is for messaging basically. And NR NTN or New Radio NTN talks about videos also. So both of these are defined in 3GPP release 17 standards. And these are the smartphones which have released their chipsets or either proposed, like iPhone 14 Pro, 14 emergency SOS, which I recently shown you the screenshot. So there the position is sent to the Global Star LEO satellites. Similarly, Samsung Exynos modem 5300 is declared to support NTN technology. Then MediaTek chipset based on these smartphones, this will be showcased in Mobile World Congress, which is scheduled in 2023. Qualcomm Snapdragon is also partnering with Iridium to offer these services in Qualcomm chipsets, which will be known as Qualcomm Snapdragon Satellite Series. And SpaceX has collaborated with T-Mobile, and there is a collaboration from Microsoft, Microsoft Azure Space Platform, and also by Skylo and Murata. So all these global players are moving to this NTN technology in future. So in future, we'll have, I think, these chipsets available in India also. Thank you for your time. Thank you. If you have any questions, we are here.
Yes, thank you, Niskamji. So with this, we come to end of our technical session. All the 4 sessions are covered now. So now this is time for question answer session. So one, Niskamji, am I audible?
Yeah, you are audible.
Yeah, there is one question. It is DD Technology sir from Maharashtra, Vikram Malviya sir has asked. What is the plan and timeline to make NavIC to have a global coverage? Is there any timeline defined?
Now, global coverage per se is currently under study phase, so there is no timeline per se defined, and it would be again in a phased manner. We may not go global directly. We may, introduce the concept where the next generation constellation design is expandable to global, where we will cater to our regional needs only, and as and when government gives approval, then we can go for global. So as of now, there is no timeline per se.
Fine. So any participant who want to ask you a question, just raise your hand. I will allow here to speak. From my side, I will unmute you. Yes, sir. Just 1 minute. Yes, sir. Please, sir. R.K. Chaudhary, sir. Please, sir. Unmute yourself, sir. Yes, sir. From my side, I have allowed you to speak, sir. Please.
Good afternoon, everybody. I'm R.K. Chaudhary, DDG from Maharashtra LSA. Sir, I have got a general question like, say, whatever NavIC satellites have been launched, are they dedicated to navigation purpose only, or they are catering to other services, other satellite services?
No, all the satellites that have been launched, they are designed for navigation services only, and the services that we had earlier listed out, which include the messaging service also. So they are designed for this specific purpose only.
Then what is the expected life of a satellite? Like something around 7 years, 8 years, or something like
no,
that?
the design life are 12 years.
12 years.
Yeah.
Okay. Thank you very much.
Thank you, sir. So any participant who want to ask question, please raise your hand. All the speakers are with us, and I will unmute you from my side. Yes, Himanshu sir. Just 1 minute. Yes, sir. Himanshu Sharma, sir. Please go ahead.
Yeah, good afternoon, sir.
Yes,
yeah,
good afternoon.
Himanshu Sharma, director from DOT. So my query is that many telecom service providers use GPS receivers in the field. So is there any NavIC receiver product in the market with which they can replace their GPS receivers?
Yes, I'm happy to say that there are many products available in Indian market pertaining to your case, like timing receivers. We have products from both Indian and foreign vendors. Even few Indian companies are there which provide you NavIC based timing receivers.
Sir, not for timing, sir. They capture lat and long of their mobile towers and their network elements. So they use GPS receivers for very high accuracy of positions for capturing latitude and longitude. So, sir, GPS NavIC receivers for capturing these lat longs.
It's a basically multi-constellation receiver. So it is also capable of receiving GPS as well as NavIC. And you can choose, whether to use timing synchronization using GPS or using NavIC.
Okay, thank you.
Thank you, Himanshu sir. Thank you. Any other participant who want to put questions to our speakers?
One question from my side, Subhas.
Yes, sir. Please.
While explaining about the chipset having embedded feature of NavIC as such, the list shown does not include many of the smartphones like Samsung, etc. Only one chipset of Samsung was having NavIC. So may I know what is the regulation or compulsion to the chipset manufacturer to embed NavIC or any other GPS kind of thing?
Yeah, that's a very good question. In fact, those discussions are already on with many mobile manufacturers. There is a whole round of talks that has happened with MeitY officials, with mobile phone manufacturers to assess their preparedness, that whether is it the right time to declare support for NavIC or make it mandatory for mobile phones. So most of the manufacturers are supporting, like you mentioned, Samsung. So Samsung Exynos, only one of the chipset 980 is supporting NavIC, and more and others. There are more products available with other features. Again, it depends on their product line and their market anticipation. And once the regulation comes, all have to support. Technically, it is possible, but only thing, they have requested time from the government that please don't make it mandatory now. We need some time to implement, and in future we'll definitely comply with your views.
Some royalty arrangement is also done? You take some royalty or they take some royalty or something?
No, not in the telecom domain, but MeitY has come up with an RFP of 10 lakh chips. So where those chips, chipsets were recently manufactured, they were unveiled by Director SAC and Minister of State recently at Ahmedabad at one of the Semicon Future Design event. That NavIC chip was unveiled, and that chip will be going and be deployed in various products like vehicle trackers, and there will be subsidy will be offered by government, like based on the proof that it has been installed on a bus, so many numbers have been installed, some subsidy amount will be given by the MeitY to the manufacturers. So that program has there in that particular chip, but not so far in the telecom domain.
And
just to add to what Telecom has mentioned, as far as royalty goes, there is no such policy of putting any royalty on utilization of NavIC signals. They are free to access.
Yeah, they are free.
And one more towards the technical part, that future satellite, all the satellite from ISRO will have L1 frequency for navigation. So not only the constellation satellite forming navigation, other satellite will also be loaded with the L1 frequency elements to use as navigation.
As and when we launch the new satellites, they all will be equipped with L1, and the older one, as they retire from service, they will be replaced with newer versions. So,
newer versions.
Of course, we can't do retrospectively for already satellites that are in orbit. We can't do there.
Natural.
Yeah.
So, thank you.
Thank you, sir. Any other question if you have? Otherwise, we may proceed to end the session now. Any participant who want to put a question, please raise your hand. From my side, I will unmute and you can ask your question. Okay, fine. Okay, so with this, we come to R.K. Chaudhary, sir. Just 1 minute, sir, please. Yes, sir, please go ahead, sir.
Sir, with the present constellation of 8 satellites in orbit as of now, and hopefully we'll be launching more satellites in the orbit, what will be the estimated frequency of launching the satellite, either for the extension of service or replacement of the old satellite? Will it be something like 1 per year or something like that?
We have anticipated 2 per year, but of course these are dynamic situations based on launcher availability and the launch complex availability. But programmatically, we anticipate 2 per year.
Okay. Thank you very much. Thank you.
Thank you, sir.
So I would like to add one more point. Since you are from telecom domain, so I would request that in future, if any tenders or any RFPs are being made for your telecom domain, please include NavIC in your specifications. That will help us proliferate the use of NavIC services in your domain.
So I'll send this as feedback to you.
Yes, sir. Yes, sir. That will be very good. Acha, Niskam ji, one question from my side that what SAC is doing to promote NavIC in telecom industry? What are your efforts you are doing to, apart from like this interaction? So what you are doing from SAC side or ISRO side, what is being done to promote in NavIC?
See, as I told you, for telecom, there are 4 broad applications. First is your telecom network synchronization. So we have developed a basically timing receiver. We are showing it to different users, not only telecom, but like power sector. So we are showing that, yes, it is capable of synchronizing your networks, since everybody is used to using GPS for time synchronization. So it takes time to convince the users that, yes, you can switch now. So for synchronization, we have a product. Then if you see location-based services, so we have apps. We have shown few of them. Then there are more from NRSC, Hyderabad also. Like there is a monument is there. So you need to geotag so that so much meters from that protected monument, you should not come up with buildings. So like that, user-friendly apps are available from ISRO as a part of location-based services. For assisted NavICs, we have approached 3GPP. We have gone to include NavIC in RIL 16, and now in that NavIC is part of the standard. So any equipment which is complying to that standard automatically will have to add support for NavIC. So all these are the efforts. And as sir mentioned, like we are contacting different mobile manufacturers. We are in touch with METI and and we are convincing people that to include it in more and more products and to make mandatory it in mobile phones in the future.
Thank you. So one small addition from my side regarding your PPT, that part what Niskam ji you delivered. And I think 112 you just mentioned that probably India will come on this day. We have already come now. 112 is our national emergency helpline. Like 911 of US, India has started. 112 is our helpline also.
Yeah, thank you so much. We were not aware.
No problem, sir. I can understand that. Okay. So with this, we come to end of webinar. So, sir, DG sir, with your permission, may I propose vote of thanks for?
Yeah. Go ahead.
Yes, sir. Thank you, sir. Thank you. So I take this opportunity to thank our member services, sir. Sri Umasankar Pandey, sir, DCC member services, to spare his time from his busy schedule. I also thank Director SAC, Sri Nilesh Desai, sir. From last 2 days, there was some uncertainty. I know that how run he might have done to deliver, to be present this time. And I also thank Sri Raju Sinha, sir, and Sri Mukesh Kumar, sir, for providing all the support and guidance to conduct this webinar, and all the speakers who are here from SAC. So I was continuously in touch with Praveen Patidar, sir. So he has provided me all the logistic support and every information. I think I bothered him too much. And thank you, Praveen, sir. And I also thank Sri Dr. Chandra Prakash, sir. Actually, his topic was scheduled for Ms. Vibha Jain, and somehow at the last moment he could manage to deliver the talks. Otherwise, we could have missed that talk actually. And I also thank all the participants who have joined from different field units, different organizations of DOT, industry, and who have made this is festival time. So from their festival time also they could have managed to join this time. And I also thank my here director admin, sir, NTI PRIT, who has continuously provided support for all the logistic support, all the technical support. Director training, sir, who I think for last 2 days we are working on all this to how to make this webinar success and every thing we arranged. So with this, I thank everyone who directly or indirectly, anyhow, how they provided all the support in conducting this webinar. So with this, I seek permission from DG sir to now leave to end the meeting, sir.
Thank you. Thank you.
Yes. Thank you, sir. Thank you, sir.
Yeah. Thank you from our side. Thank you.
Yes, sir. Thank you.
Thank you. Thank you for the opportunity. Thanks.
So now I'm ending the meeting. Everyone may please leave if you want. Thank you.
Save the recordings first, please.
Yes, sir.